I think you can start it.
Okay, so today we're going to solve LeetCode 632 called the smallest range covering all elements from k-lists. So we have an input array here in sorted order, so that's good, in non-decreasing order, which basically just means equal to or bigger than. So we want to find the smallest range that includes one number from each of the k-lists. Define a range AB as smaller than CD if B minus A is less than D minus C. So difference between these two elements is basically if C and D is inside of A and B or vice versa, then it covers a smaller range. So we want to find the smallest possible range, and you can see 2024 is here because 20 is inside of here, 20 is inside of here, 24 is within this range. So, okay. So we want to find a range that's the smallest. So that makes it really challenging. And the way to do this is by using a heap. So what we're going to do is start with the biggest possible range from 0 to infinity, and we're going to work our way down by selecting, first of all, the smallest element from each sublist, finding the maximum of that, and then pushing that onto our heap, and then popping from our heap until we can find the reverse, which is going to be the smallest number from the biggest numbers. So we're going to keep iterating. We're going to add 4 to our heap, 0 to our heap, 5 to our heap, find the maximum, we get 5. Then we're going to add 10 to the heap, 12 to the heap, 18 to the heap, find the maximum, we're going to get 18. Then we're going to add 15, 20, and 22, find the maximum is 22. And then after that, 26, 20, and 30. And basically, we're just going to keep covering elements to see if they're inside of the input and to see if they cover throughout all the ranges. So, well, obviously, first, what we want to do is we want to iterate over our input. So let's declare a variable called myHeap, and let's declare the length of the input. You can do it many ways, but this is how to do it. And we're going to set a variable called high to float of negative infinity because anything is bigger than negative infinity, and it's going to prove to be useful later on. And this is important. This is actually going to be our result, which, anything is smaller than the range 0 to infinity. So after we have these 4 variables, we're going to use a heap to do this. Obviously, we want the input. So we're going to iterate through our input list of lists. And again, we're going to push the first element of each sublist, the 0th index, onto the heap. And while we're doing this, we are going to, so we're pushing the 0th index. We're going to keep track of the index, the sublist we're on. And we're putting 0 here because we're pushing the 0th element onto the heap. So this is the value. This is the particular sublist. So this can be 0, 1, 2, and then this is just the first sublist. So obviously high is going to always be updated on the first turn because it was negative infinity. And now we're going to have to keep popping until our heap is empty. And the reason we're doing this is because as long as the heap has numbers inside of it, as long as the heap has pairs inside of it, we still have the possibility to find a smaller number. So cool. So now we have high. How do we find low? Well, the lowest element is going to be popped from our min heap.
Okay.
Because min heaps in Python mean that the smallest element is at the root of the heap.
Okay.
So now this is going to be, we have to finish this first, and then this is going to be 0. And then the index is going to be 1. And then the index in the list is going to be 0 too, because 0 is the 0th index of this particular list. And so this might be confusing now, but the most important part is we have our current range. So current range is high minus low, because that's smaller than what we had before, 0 to float infinity. And we're going to ask the question if the first index, the float infinity minus 0, is bigger than high minus low. That's always going to be the case in the first term. So then we can just update p to be low and high, because we want the smallest possible index, or the smallest range. And notice how in our input we need to include at least one number from each of the k lists. So this means that while we finish iterating through our sublist, meaning we're out of bounds, if I is bigger than if index in list is bigger than equal to length of nums I minus 1, because we're working with indexes, so we have to do the minus 1, then we can just return p, because we already know that
It's out of bound, right?
we finished one of the sublists. If we finish even one of the sublists, then we're already violating our condition, because we have to find at least one number from each of the k lists.
Okay.
If this is not the case, then we possibly have even a smaller result. So we're going to push onto our heap again. Now we're going to add the first indexed element of each sublist. So nums of I index in list plus 1, because notice how index in list is 0 here, because like I said, this is going to be the index in each sublist, while this is the overall which sublist we're on, if that makes sense. So we're going to have index in list. We're going to push that value. We're going to have I, and then we're going to, this is not going to be 0 anymore. It's going to be index in list plus 1, because now we're on index 1. Low is found here. So now that we pushed a new element onto our sublist, we always have to update high value with whatever element we just pushed, which is the value. So for example, nums of I1 is going to be 10. If 10 was bigger than 5, so now high becomes 10. And so, yeah, this is it. And it's going to keep running until the heap becomes empty, because the heap is going to hold the smallest or the largest element. And then we can also take advantage of the heap invariant to get the smallest element as well. So this is always, just to make this clear, this is always going to be true in the first turn, because this is, anything is closer together than this. And there's the same reason why float negative infinity, because again, anything is bigger than negative infinity. Okay.
Mm-hmm.
So as you can see, it passes all the test cases.
Yeah.
And yeah, this is might be a little hard to understand, but I think that this is a pretty good heap question, because it deals with input ranges. It's a little bit similar to the intervals intersection concept, because you're trying to find one number from each of the sublists, and then you're trying to find the smallest range as well. So
Wow, okay. It's good to learn. I didn't solve this question, so I think your explanation is good. And then can you tell me the time complexity on this question?
time complexity is O of n, because we're only iterating.
Well, hold on. Why is B? Did you sort it? Are you sorting?
No, you don't need to sort it, because we're using a heap.
I'm not sure.
And plus
Python.
the input is already sorted in non-decreasing order. You don't need to sort anything. Notice how this is already sorted.
Okay. Okay, I'm not sure because in the Python the min heap, because you are using a priority queue, right? So internally,
maybe this will make it easier. So, okay, so notice here this is 400.
Mm-hmm.
So first value. Then the second value, notice, is 010, because this value happens to be 0, right?
Yeah, correct.
And then the third value is 5, which is at 012, the second sublist. and that is still the 0th element, right? And then what happens when we do low? Well, we're going to pop based on the smallest element. So we're going to get this guy first. Because the smallest element is always at the root of a min heap. It's the opposite. You know how a max heap works in Java? It's the exact opposite. So notice how this is 0, right?
Yeah, correct.
So because obviously that's how we get low. So if that makes sense, because the lowest is always the smallest, and the smallest is at the root of the min heap, so we can just pop from the min heap, right?
Yeah, correct. Yeah. Yeah, sound good? Okay, I will start recording.